Hello, it's Muhammad Rajab, a research fellow in Southampton University. Welcome to ESPRESSO, a system for secure keyword search in decentralized environments. In decentralized data cooperatives, such as healthcare networks or data markets, users own and control their data, which enhances user autonomy. However, enabling privacy-preserving search across these distributed environments is still challenging. Here is why. Users set individual varying access permissions to their data for different individuals. Traditional search violates privacy by aggregating data into a centralized index. As a motivating scenario, imagine a medical research institute searching for patients with rare conditions across multiple hospitals. Each patient controls various access permissions to their data for different researchers, and thus different search parties might get different results for the same query based on their granted access rights. Our ESPRESSO framework tackles these challenges with three key pillars: decentralized indexing, where users control different visibility to their data for different search parties with local data stores indexes; metadata-driven selection, ensuring queries target only relevant sources, servers, and their pods; and decentralized ranking, balancing relevance, access, and privacy. Our demo simulates the real-world scenario that we described earlier with 50 servers hosting 9,500 pods, each representing a patient's medical history. For this demo, we have set up 5 web IDs for search parties whose data access rights vary from 5% to 100% visibility of the total data. And now let's check how ESPRESSO works in action using some scenarios. Going to the user interface of ESPRESSO, let's have an example of a pod with a single medical history. Let's imagine this is Alice's pod, and this is a medical history of Alice. And in this medical history, we can see this is like a long text of the medical history of Alice. If we go back here and we go to the ESPRESSO index, the local index of Alice's pod, we will see that Alice have given access to her medical history for 2 search parties, 3 and 5, let's say Pop and Carol. And if we want to search now the ESPRESSO system for this keyword and for the web ID of Pop, let's see if Pop indeed has access to Alice's pod. Yes, it has access to the medical history of Alice. And now let's check if Carol also has access, which is the other web ID here. And we search, we should get the same document retrieved. Yes, indeed. But if we want to select with invalid or unauthorized search party web ID, we will get no results. Now let's go to another scenario, which is we have prepared some web IDs with different access percentages for the sake of the demo. If we search it with web ID with 5% access to the whole data, yes, indeed, it retrieves like some results here for the whole network. And we have 5 documents retrieved out of 475 KDocs spread over 50 servers here. We have 50 servers, as we have mentioned, but only 5 servers have been selected using the metadata, and 5 pods on these servers have been selected. We will skip the other percentages for the sake of the time, but we obviously will get more results, and it will take more time. If we want now to do another scenario in our demo, let's use the refine search or select specific sources, servers, or pods. So we can refine the search. So maybe the search party or the researcher is interested in selecting specific, let's say, hospitals or servers with their patients or pods here. So maybe we are interested in these 3 servers or 3 hospitals with their patients instead of these 5. So we can do that using ESPRESSO, and now we have, yes, 3 servers and 3 pods and 3 documents. We can do another thing, which is maybe that we are interested in querying the top 2 servers and the top 1 pod at each server. So we want to query that, and we search again. And indeed, we get two results out of the full result. So the last thing that we can do is let's search without results, but these results are not ranked by any score, as you can see. What we can do is we can rank. We have different ranking algorithms, but let's go with the default BM25 that we set up. But we can search we can re-rank with any other algorithm. So let's search ranking the results using BM25. This should rank the results using the BM25 score. Yeah, indeed, it retrieves the results, and these results now, they are all ranked using the rank score. That's all from my side. Thank you very much for watching.